This is actually an advanced technique as far as Git goes. We're going to look at what it can do for you, how it works. We'll do a live demo. No good presentation is complete without a live demo with unexpected bugs and tribulations, so look forward to that. And we'll talk about why the quality of commits matter when it comes to making something like Git bisect useful. First of all, most importantly, what can Git bisect do for you? Imagine there's a terrible bug in production or in your pull request or whatever it is. We've all been there, and there's this pressure to fix it fast. And a lot of times there's a temptation to kind of go monkey patch something or do some fast hot fix without actually understanding what happened. What Git bisect can do is help you understand what you need to know to fix the bug and truly fix it so it doesn't come back, what's causing it, when did it start, why did it happen, and probably most importantly, that's the one that's the hardest to remember, what opportunities do we have for making sure this kind of thing doesn't happen in the future, who might need some extra perspective, who is aware of complexity that maybe we weren't, that it wasn't thought of. Git bisect tells you exactly, given a massive sequence of commits, which commit first introduced the problem, and it does so in a pretty fast way. It'll tell you the problem was caused by this specific commit. You know when it happened. We know what code was in the commit, so figure it out, something in here. And it tells you who was involved, either as a subject matter expert or maybe someone that hasn't had the opportunity to step on the landmine that you may have in your career, and you might be able to share that trauma. How does Git bisect work? Well, it performs a binary search on a range of commits. So given a whole lot of commits, we know one is bad, right? So let's assume, okay, there's some bug in production. We're going to go to that commit and we're going to mark it as bad with Git bisect bad. We will then check out a commit that does not contain whatever bad thing we are looking for and run that commit to verify the bad thing is not there and mark it with Git bisect good. Git will then automatically pick the middle commit between them and check that out for you. Then it will say, hey, tell me, is it good or bad? So we have to run it. We'll say, okay, this one's good. Great. Git automatically knows if the ones between those two good commits were all good, then problem didn't start here. So then it does that divide and conquer. We repeat the process. That one's bad. Okay, so problem, it was bad in that direction. Check that one. This one's bad. All right. Well, what about this one? You tell me. It's good. So then Git tells you, hey, the first bad commit was right here. So why Git bisect? We've got 10 commits. You could just step through them and check each one. But oftentimes we don't know how long a bug has been around. And I find myself even having to go back 100 commits go back 1,000 commits. When did this even start? So how fast is binary search? Fast. Finding a problem in 10 commits takes about 3 tries, 100 commits roughly 5, 1,000 commits roughly 7. Going through 10,000 commits is only going to take us 10 tries, so that makes us ridiculously efficient at finding issues. So, demo time. Let's actually check it out. I've got it running here. Relatively standard create React app. There's a problem here because we're bragging about a rotating logo and it's not rotating. We'll use Git bisect to try and figure this out. Our first step was to be on a bad commit, so we're on the tip of main here. Git bisect bad. And it's going to ask us, do you want to start the Git bisect process? So in this case, yes, press enter. We need to find when this problem was not present. I happen to know that there are 19 commits, the second of which was the create React app. So we're going to go back to there. So git checkout head, which is where I currently am. Tilde means a certain number back from where I am, and I'm going to go back 17. All right, great. Head is now there. Now, we know React loves to use hot reloading, but sometimes there can be issues, especially when you're going back and forth across a whole bunch of commits. So I'm going to go ahead and refresh anyway, just to see. Oh, yep, our thing is animating. That's the problem we're trying to solve very specifically. So git bisect good. Great, fantastic. And it has now jumped to a middle commit. Apparently a commit where somebody had remembered Hamster Dance from 1999 and decided that it was a good idea. So the important thing is to remember what problem we're trying to solve. So is this a good commit? Yes. So git bisect good. It's still rotating, but I'm going to go ahead and refresh just to make sure the hot reloading isn't messing with me. And oh, look, it actually is. It's not rotating. So git bisect. Again, I'm going to refresh just to double check. No, I can smash refresh. It's still not rotating. Git bisect bad. And hey, it started rotating, so it seems like hot reloading is working, but I don't trust it. I'm going to refresh. Yep, it's working. So git bisect good. All right, it's telling me the first bad commit, and if we actually look at the contents of that commit, what was the message? What was it trying to do? Make the logo bigger. Okay, great. There are no ands in there. That's a very clear commit. It's telling us one thing that it's trying to accomplish. Going from 40 to 50 seems legit. It's accomplishing what we want, but there's a contrived typo that was put in there to illustrate the point. So we know the way to fix this bug is just to revert this line. That's Git bisect in a nutshell. In order to be able to use Git bisect, you have to be able to run these commits to know if they're good or bad. Imagine in our previous example, that middle commit that we happen to pick, say it's missing a file. So when you yarn start, it politely tells you not going to run for you. Or we go in and everything runs okay, but when we go into the browser, there's a runtime exception, so we can't actually validate whether the thing is rotating or not. Or in more complex apps, the routing is broken and you can't get to the page that you need to. That's why it's incredibly important to make sure that in your series of commits, each of those commits actually works. Assuming you're able to actually find the right commit and identify where the problem started, you have to be able to understand what part of that commit caused the breaking change, right? So we've all seen this in our career, the 1,255 line PRs, where it is just really difficult to understand and you have to parse through, and you might as well just have checked like 1,000 commits manually because you've got thousands of lines to now sort through. I really dislike squash and merge for pull requests, because when you do squash them down, you're faced with something in that massive change caused a problem. Great, that's useful. Not at all. When it comes to Git bisect, our commits should be atomic, of course. We all know this. They should do one thing so that they're easy to understand. Equally importantly, they should pass all tests, because there are times where what you're hunting down is not necessarily a feature bug, but a breakdown in your testing. If you make a change to a component and that breaks the test, fix the test in the same commit. So there we go. I think I'm out of useful words. I would love to have people with experience with this correct me when I'm wrong, pile on when I'm right. What are your thoughts? And is this useful?